let's try again, and let's use OpenSSL, and this a command called general. There's two commands. One is generate RSA. This command will give you some the RSA parameters I mentioned before, but this tool has been suspended since maybe last version of OpenSSL. Now they try to, because there are different public key ciphers, they try to make it easier, like to consistent for all the ciphers. So it's better to use a kind of a general command and then to specify what is a cipher you want to use, what is a parameters you want to generate for different kind of ciphers. Then here I can use what is this one? Let me check. Okay, it's let's see commands. Help. Inside this standard command, this is the group. You see this generate key with P. You can consider it a generate public key. And this is a standard command. I recommend to stick to use this one to avoid some confusion, because generate RSA, that one could be removed after several updates of OpenSSL. It's better to stick to the standard usage of OpenSSL. So we use a generate P key here. I clear the screen, and then I use OpenSSL and generate public key. This is a command. I need to specify which algorithm I want to use to generate. Then I need to type algorithm, then RSA. And by doing this, that's fine. And let's see how it works. Yeah, I was given this key. This is the output of the key that is used in OpenSSL. And from here, you don't really see what it is. It's just a mess. And you have no idea how long is a prime, how long is integer n, and what is the integer e. You have no idea here, right? And in fact, we can use another command that's called p key. Let's show you. Let me help. There's another command called public key. This is p key. This command is used to manage the private key, public key for different ciphers. So here, and for what I have shown here, like first I need to output my private key into a file, and then in that file I will use this command p key to try to get the information of the public key, try to get information of the private key, all the information. And so what I should do is like this algorithm RSA, and in some cases I need to specify the number of bits. Here, let me see. It was not in this, then I will skip this part, and let's directly I will output the key that is generated in this command to a file. That's right, private key. I write RSA private key. And in OpenSSL, they use two formats. One is this PEM. That's the format they use to store the private key. Because mostly when we generate this key, we prefer this private key to kept a secret, right? That's what we have learned, and we don't want this private key to be seen by others. So it's definitely not a good practice. Okay, you just generate a private key and then display it on the screen, then someone could see it, right? And so it's good to store in some file. And here, let's store in this file. Okay, I already stored. And if I look at this this generated key, RSA, provide key, it's again the same information, but I can use the command OpenSSL, this p key, this command, and I take this file as the input, RSA private key. Then I can output it with an option called text. This text option will give you the user that all the all the parameters that can be readable by a human being, not this mess. If I you see, this is a command, and this is the input, and this input, from this input, by using this command, it gives you some information here. And RSA, then you can read it. This RSA, the private key, it has 2048 bits. That's 2 primes, and the modular, this modular is n. That's a product of these 2 primes. It is given in this hexadecimal form. This is the modular. And here, that's this part is n. And mostly the public key in most RSA is used as this number 65,537. Is this E that we introduce? We choose 3, but of course 3 is not good, right? And what's you see here, this is a hexadecimal form, OX1001. And in fact, this is the integer E, 2 to the power 16 plus 1. That's the typical E used in most RSA. Some of the RSA use E as 2 to the power 6, 2 to the power 4 plus 1. That's 17. That's also a choice. But for better security, people mostly choose 2 to the power 16 plus 1. The reason for choosing a little to choose E bigger is like if E is chosen as 3, then there's some algorithm to directly calculate the qubit root of the ciphertext. Then that's if we can directly calculate some inputs to the qubit root, then it's a decryption. So that's not good. Since E is 3, it's lower. Then some attackers will use some available algorithm directly calculate the qubit root of the input. And the reason why it has this format is 2 to the power 16 plus 1 is that when we try to do this calculation, it takes quite a long time, and use this format by using further improved steps in this process, this m to the power e modulo n. In these steps, we can speed up. So here we can speed it. So we try to use some algorithm to decrease the complexity of encryption process. And by that algorithm, then it's better to choose E with very small number of ones in its binary format. So that's the reason here. We only have 2 ones in its format, in its binary form. And that's the best we can do. And based on this public exponent, then we have this private exponent. It's D here. You see this D is very big and it's quite massive compared to E, the form, right? It's much more complex than the encryption exponent E. And here, these are the two primes, P and Q. Prime 1 and prime 2. These are two primes. And there are some extra information. It's exponent 1, exponent 2, and the coefficient. And in fact, these three extra parameters is used in practice. And we have mentioned when in the decryption, we need to calculate C to the power D modulo n. And D is a mess. It's very complicated. So they use some extra algorithm to speed up the process. And in those algorithms, three extra parameters are needed in the decryption process. That's in practice. Even though by using different algorithms, still the decryption process is rather slow. It's much slower than encryption process. So this is the way we see the encryption key and the decryption key. So this is a typical format of RSA key parameters. And here, now we have these parameters. I want to use this parameter to encrypt some file and then to decrypt some file, just to demonstrate this also works. And I think that's pretty much the time we can use. So I can first input some file, some information to, let's see, hello RSA. Then I input into file 1 text. So this is a file I want to encrypt, and then with this command, I need to use another command in OpenSSL help. We have this P key. That's to manage the public key and the private key in most of the public ciphers. And there's another one, this P key utility. This command is used to use some key to encrypt, to sign some document. And for RSA, it also has RSA. Because RSA is quite special, so they also developed a special command for RSA. I don't recommend you to use this one. The usage of RSA util and the P key util is basically the same. You use it in the same format. But I don't recommend you to use this one. It's better to just follow it and then specify the RSA. It's better. Let's try this command. OpenSSL, then P key UTL. Then let's see how can we use it. Then you type help, then it gives information. Then in is the input file, and then you may want to also output your file. Then you have this output file, and then here for mostly you need to specify the key for encryption. Then this, okay, what is a public key for the encryption? And for different, if you use the private key, then it's a process of sign and verification. And if you use public key, then it corresponds to encryption, encrypt, and decrypt. These two. And here, let's do encrypt. OpenSSL and PKey UTL. Then here we already have this input key. Here we need to specify the input, that's file 1. And we also want to specify the input. I don't remember this command. Let's use public key in. That we want to encrypt with public key. And here we specify public key. Then we have. Oh, I haven't encrypted this. Let's try it first. Maybe I also need to give it the exact format of the public key. And let's specify algorithm RSA. Here it's not correct. Maybe I don't need to specify RSA. It's again not correct RSA. Let's use OpenSSL, the other command. RSA due to the time limit. RSA UTL. Then I specify in file 1 text. Tab in. Let's see whether it works. It's still not working. So one reason for this could be I haven't output the public key to a specifier. Let's try and use this, try to do it, OpenSSL. Then I use a P key. Then I take the input RSA, private key, and then I need to specify the output. Yes, then RSA key.pub. Let's try again.
It's the file name that's wrong.
File name is wrong?
File T1 is the file.
Okay, thanks. Thanks. Public key, and let's see, RSA key. It's correct here. Alt pass in. Okay, let's skip this demo. We will try this next time. And before this, I want to demonstrate another command for you, because I mentioned for public key, for this private key, when we generate, we don't want to store it in plain text. Otherwise, there's no sense, right? We want to store it in encrypted form. And here, when we generate this key, when we generate OpenSSL, we generate the public key, and we can specify we want to use some cipher to encrypt our private key. And here algorithm and then RSA. Suppose I want to encrypt with AES, like 256 CBC. So previously we don't have this AES in the end. Then we will output our file in private form. Then we directly output to the text. Then it's in plain text file. It's not good. And here, algorithm. It's again. Here, then here you see we are asked to type in our password. And this password will be used to generate encryption key for AES. And then that key will be used to encrypt our private key. So I type, suppose I only type SD, 3 letters. And here it pops up this error message. So you must type in 4 to 100 with 1023 characters to make sure you have strong enough password. So it refused to accept shorter key. So I type a little longer key and 5 letter A to G. Then I can see this. Then okay, it's encrypted. Let's see whether we can use OpenSSL. We have this P key. That's what we have demonstrated. RSA private form. Previously, we used this to directly to display the private key, all the parameters, key parameters in plain text form. Now here, I cannot do it. I have to input the password that I have previously used. Then here, I can see it. So this is normally the typical practice if we want to generate some private key and public key of RSA, like especially as an administrator. Then we use it. Then we always need to type the password to use some algorithm to encrypt our private key. Otherwise, then no matter how strong the RSA algorithm is used, then you just store this private key in plain text form. Then that's rather bad practice. There's no security at all in this scenario. So that's also the reason it's better to have this, to keep this in mind. If later on, if you are working at some company, then you are administrator, and then you create something. For this private key, don't forget to encrypt it. Okay, yeah, that's it.